Okay, looks like we're recording and we're sharing the screen, so we're good to go. This is part two of this is the second of the pre-recorded screencasts that I told everybody, I told all of you that I would record for you. These deal, of course, with the work that's due here in Module 14. In Module 14, of course, we talked about the PDC model, that is the tree or the branch probabilities. We saw that model, and you can take a look at the key there that was due, and that's in terms of using that probabilistic model to come up with expected values to look at the possible outcomes or the range of possible outcomes that you're going to encounter in a given decision. In Chapter 14, we move into a different environment, which is closer to what we do in the real world, and that is where we have to make a decision on the basis of multiple criteria. And so obviously Chapter 14 deals with what we call multi-criteria decisions. And I wanted to just stop for a moment and take a breath, because this is kind of a significant departure from where we've been. What we've been doing earlier is we've been using the optimization model, where we have an objective function that is a mathematical expression of something that I want to accomplish. Then, of course, we've identified the variables that we need to change. All right, we've talked about that. We started with one, and then I think we even looked at using a scenario manager to change several variables. And then finally, we build in the constraints. And I gave you all of the caveats, qualifiers, etc., about where you get those numbers, how they're computed. And then we also talked about simulating data that would give us as wide a range of potential outcomes, knowing that when we make decisions, that they're not binary. When we make decisions, they run along a continuum. And we talked about that quadrant, famous quadrant I had, where we could start in the northwest corner, and we have condition or state of nature 1, and then in the northeast corner, condition 2 or state of nature number 2, and then in the southwest corner of that quadrant, we'd see what's the outcome of those two. What we would have, say, alternative or option 2, and then in the southwest quadrant we would have let's go along the vertical. On the vertical side, we'd have on the vertical side to the left, we'd have the option 1 or alternative 1 or action number 1, and then right below that, action or alternative number 2. And then within the quadrant, we would see the outcomes of the decision given a particular set of conditions. And of course, as I said, you can run that all the way out as far as you want to go, as long as the probabilities for those conditions add up to 1. And you could run as many alternatives or options in terms of response to what you think will be the conditions that you can choose. And so and then of course, once having attached the probabilities, we can start to expect we can start to look at computing the expected value. And then we looked at the expected value of perfect information. We saw some variations of that back in Chapter 13. But here in Chapter 14, we're using multiple criteria, and we're basically doing some prioritizing using some scoring models. And one of those that we run into is the analytical hierarchy process, and then pairwise comparisons using a pairwise comparison matrix. Now, as I had said before, and as I've said every week throughout the course, one of the key components of management science is that we understand the difference between decision-making and problem-solving, okay? We may know how to solve a problem, we may just decide not to do it, or we may not do it very well. The second thing is that management science is predicated on the idea that we can find models out in the real world that we can use to understand or to simplify situations or problems that we encounter. And certainly when we talk about the multiple criteria problems, the idea, the analytical hierarchy process just simply says that we have a problem and then we break it down into its components. It's really no different than in biology, where you have a different species and different subspecies, and it's really the same as we see as I provide an example there for you in terms of a matrix, and we see that matrix is a model for pairwise comparison. Okay, and so we use some models that are out in nature, like the analytical hierarchy process. We take a human body, we break it down to its components, and then its subcomponents, etc. In the scoring model, in that problem, we're going to use pairwise comparisons, so we can come to the point where we determine what set of criteria are driving our decision. Now, it's very, very important for you to understand that the data that get put into the matrix in the comparisons, okay, that data, those data are inputted on the basis usually of a ranking, and we'll see this. And so it's subjective in nature, but we believe, or we operate on the belief, that I can differentiate between 5 things and choose the first what's most important, and the second, third, fourth, and fifth. Now, having taken statistics, 2 or 3 statistics courses with a mathematician who also had a degree in psychology, he hated ordinal scales, hated using what we call Likert scales, because they're not, he said, they don't produce real numbers. And he's true, he's correct. And I don't know that if you could really say, today let's say, like similar to this problem that we're going to work with, gee, I want to work in Chicago. But my second choice, if not Chicago, would be St. Louis. And if it's not my third choice, it would be Dallas. And if it's my fourth choice, it would be San Antonio. And finally, of those 5, the one I would least like would be, let's say, New Orleans. Do I know that I really feel that strongly that I have such a 5 times greater for Chicago than New Orleans? Mathematically, I can't prove that. And on any given day, scaling, I don't care what anybody tells you, is an inexact science. And people who publish and write stuff about that, who claim to be able to discern that, are fooling themselves. It's like they say, figures lie and liars figure. But we can try to use this method as a way to take multi-criteria decisions and make the best of them. Remember, as I've said to you, when we did even the simple optimization problems, the objective function, the changing variables, and the constraints, those are figures put into a blender called optimizer that does the math for us. As the human being, it's our responsibility to make sure that the figures we put into the machine are good figures. The only, and I can repeat that to you over and over and over again, okay? And this is the voice of experience saying to you, you're going to see this more times than not, that people will construct a beautiful model, but then they won't put in the right data, or the data they put in will be fudged. And look, it's no different than driving a car. You can have the best braking system in a vehicle possible, but if you're driving down mountain roads at an excessive speed and you're not a trained driver, you're probably going to go off the side of the mountain. And you've got to always remember that these beautifully constructed scientific theory, these beautifully constructed mathematical models, here's the strength, their great weakness is they're contaminated by human data, okay? Only God could put in the perfect information, okay? Because as human beings, we're flawed, okay? That's why I pointed you to one of the readings about one of the readings that dealt with Herbert Simon and satisficing and bounded rationality, okay? And of course, the greatest example of bounded rationality is what's known as Pascal's wager. Pascal's wager, you probably heard it, is quite simple. I know as a human being I'm going to die, okay? So here's the thing. If I choose to not accept Christ as my Savior and I choose to live my life without Him, all right, when I die, I will find out that was either true, and now I'm in big peril because I'm going to be separated from God. That's what hell is separation from God, complete separation. Or if it's not true, and I come back as a flower, or I die and it's just like turning off a light and I don't know, I just go into oblivion. That's Pascal's wager. And Pascal said, the decision you're making deals with a whole lot more time than this temporal life that you and I have. And I can assure you that it's short. As all of you know, I went to school at OBU, and I remember walking through those very gates over there, through the old wall that was put up by a class, I think in 1910 or something like this, or 1920. And I remember the trees that were there when I was your age, buildings that were there when I was your age, and it's like the blink of an eye. So Pascal said, this life is very short. So you're making a quick decision. On the other hand, if I go ahead and accept Christ and I live my life, Pascal said, I'm if I wake up and after death and it was true, then I'm good. I'm with Christ for eternity, and I have that wonderful joy of being in fully in God's presence. And if I'm not, and the switch goes off and I'm just in oblivion, or I come back as a flower, who knows or who cares? So we have those decision criteria, and the models are inherently flawed because the models have data inputted by humans. However, God in His grace always provides us a way to work things out. And one of them is the law of large numbers. Many of you have experienced, or in the next 10 to 15 years, because of your age and place in life, are going to experience some really good and some really bad things. I can guarantee you in the next 20 years, you definitely will. Okay? And that's just called law of large numbers. The longer you live, the more times you're going to scratch your head and yell, I don't believe I actually saw this happen. But trust me, it'll happen. So when you've heard me talk about using the optimizer and building and using the random function or the rand between function to generate 1,000 or 2,000 or how many ever thousands of trials, the whole point is to just simply use the law of large numbers as a way to see the potential variation of outcomes that you can get. Okay? And so we talked about that. And really, when you did the PDC tree model, you really saw that branching probabilities. Okay? Because every decision, as we know, is not binary. It has all kinds of permutations or a full range. And for us, it's our job to try to say, how big is the range of potential outcomes here? And the larger that range of outcomes, the greater the risk. And so we have to figure out, okay, how do I hedge that risk? And now, when we get over here to multi-criteria decisions in Chapter 14, we've kind of we've taken a step, we went through a doorway into a different world, a more realistic world where I have competing criteria, or I'm aware of multiple choices, and I have to try to sort out what is it that I really want. Okay. And it's like anything. You're going to have criteria, and you're going to make a decision on the basis of them. So, Chapter 14 walks us through that kind of new land that we've entered, this door we've gone through, and into the world of multiple decision making. And over here in 14.4 and 14.3 and 14.4, we see the scoring models, and then we deal with the analytical hierarchy process, and then in 14.5, how do we establish priorities? And then here in 14.6, we use AHP to develop an overall priority ranking. And then in the appendix, we see scoring models using Excel. And so we're going to take a look at that and work with it. Now, again, the chapter is going to walks us through that process. And I'm not going to sit here and parrot the chapters. What I do want to do is to just take some time and quickly work through some of this. So we're going to talk about the goal programming and trying to create some graphical solutions using that formulation. And here they're trying to decide a stock portfolio. And then you see we begin to come up with some primary goals. Then they begin to decide to devise some constraints, And then we have some proxies called, rather than decision variables, they are deviation variables. And we come up with some preemptive procedures. And the book is going to walk you through the graphical solution method. We talked about this the other day so that you can see for yourself using linear algebra that here's the feasible decision area. And notice there is a totally optimal point, but we have a feasible decision area. I can't emphasize that enough to you. So when you hear me say that the potential outcomes can range from that's pretty much what I expected, to oh, what happened, to wow, what happened. You see that here in figure 14.1. Okay, and you should always remember that. There's one other piece to this, and that you should always remember. Every decision has unintended consequences. It has unintended consequences, no matter how big or how small. Now, it would be easy to ensnare yourself in it, put yourself into a quicksand of indecision, knowing all of this. But that's why, just like Proverbs tells us, many heads, many people giving you input can give you a better decision. Our Proverbs says the wise person seeks out counsel of many. And there's a lot of truth to that. And if you're a good decision maker, you will. There will be those times when you'll have to make a decision. You won't have time to think and ponder and consult. And that's where the value of your experience, it comes into play. And when you reflect on your experience, that's when you become a really valuable employee and an excellent decision maker. We'll pop back over here, and of course, they walk us through. They give us the best solution. Of course, as we see that, we talked about that. And the goal programming model, which is used to solve more complex problems. And they walk us through each of these goals. And then we come up, and here we're using solver. As you can see, we have two criteria. We want to minimize these two figures subject to these goals. Rather than constraints, these are goals. So we just took the model, okay, and when you think about this, look at this for just a moment. You're going to see we have an objective function, okay, and then rather than constraints, we have goals. And here they give you the output, the optimal value. Now, the chapter moves us into scoring models, and that's what I want to talk about here today. And here we have this decision-making process that this individual is going through. And this individual has the criteria, and let me put on the annotator here for a minute so I can put it on the spotlight. Okay, here are the criteria. Okay, and then there are 5 of those, because we know 1, 2, 3, 4, 5. Wait a minute, I've got 1, 2, 3, 4, 5, 6, 7. Okay. And step 2, we assign a weight to each of these. And the weight is very important, somewhat important, average important, somewhat unimportant, very important. Now, one of the things that I don't like about what they've done here is that we have very important and very unimportant. Okay, those are two polar opposites of the scale. That works. I have average importance. Okay, that's the middle point. But it's these here that it says somewhat important or somewhat unimportant. This probably would be better stated as above average in importance and below average in importance. You say, why? Because you want to have clear symmetry in your language. So if you ever do something like this, or you ever see someone execute this, you want to make sure that the language is consistent. And the language here isn't consistent. When I say it was somewhat important, how much different is that than average importance? I'm not sure. But if I say above average, okay, that helps me understand that it's between very important and average. You say, you're wasting time talking about this. This is gibberish. No, it's not, because these are the starting assumptions that I'm working with. And if I don't use the kind of vocabulary that really denotes what I'm trying to build, then I'm probably not going to be too clear on what I put into the model. Where here we have the 7 job selection criteria, okay? And we give a weight to each of them. And you're going to notice that some of those have equal weights. Anytime you see anyone do something like this, or you see, maybe you go to graduate school and you see a research paper where someone has given the weights and they go from 7 to 1, run, because that's not realistic. This is more realistic because it shows you a couple of things that are very important. And these multiple occurrences of 5, or multiple occurrences of 3, or multiple occurrences of 2 or 4, okay? So we have 2 that occurs only once, but we have multiple occurrences of 5, 4, does 3 occur twice? Yes, but 2 does not. This is realistic because this is why we're using this is why we're using this model or this tool in the first place, is because we need to really clarify what it is we want. Okay. One of the things that long ago that I learned when I worked in the consulting business was to just simply ask a client, what do you want? And if I couldn't get a clear answer, then I knew that part of the time with that client was going to have to be spent in trying to help them figure out what they want. Now, I never threw something like this at somebody, this pairwise comparison, because they would throw me out of the office. But I tried to work them down to what is it that's driving your need to have a team of us in here for X amount of dollars, or what is it that's really bugging you, or what's going on, and then try to attach it to something in terms of the operation. Okay, is this something you can, and once we had that, the next question was, is this something you can do something about? You have the resources to change things. Do you have the authority to change things? Do you have both? And that was obviously to help them get honed in on why we were there. Okay. Now, this is very realistic because it shows me that there's some conflict between I want to enjoy my work, but I want to have career advancement, and sometimes that's just not possible. I want to have great. I want to work where management style is, pretty good, but I want some job security. Okay, so this is quite realistic in the sense of showing me these conflicting goals that I've got. Now, this is if you should have taken your finance course by now, and I hope you covered capital budgeting and covered it sufficient to understand this issue of capital rationing. This is not too much different. In capital rationing, we say, okay, I have $1 million. I've got 6 projects. I'm going to use a tool to try to figure out which project or projects can I afford, okay? And so I could compute the internal rate of return for each of those if I assume that every single time the return will be the same, which is a big assumption, a huge weakness of internal rate of return. I could use the net present value, which has its own weaknesses or strengths. I could use free cash flows that are there, which starts to get me into the realm of raw dollars. Okay. And if I spend $1 million to get a free cash flow of $1,000, I'm pretty stupid. If I've got a project that I can spend $50,000 on and get free cash flows of $5,000. So in trying to prioritize those projects, okay, where they're not mutually independent, where they're not mutually independent. In other words, I've got enough money to run all of them, and one doesn't have to happen. If I do one, I don't have to do the other. Okay, the same kind of story here. And here we look at the financial analyst position in Chicago. And the ratings. And we come up with some of those ratings. And I'll walk you over to the AHP. Now, you talked about this in terms of the hierarchy. So again, I want to move us on over towards the pairwise comparisons. And this is, now we move into the scoring model where we're going to try to build a matrix that helps us decide, okay, what we're going to do. And we've got these pairwise comparisons and we assign a numerical rating to them. And we use that to as they say over here, right here, we use it to the pairwise comparisons to help the decision maker determine their priorities. And we start with the matrix, okay? And we have those first sets of comparisons. Okay. And then we put in a 1 when we compare each thing against itself. That's the diagonal. And then they begin to show us how to fill in the remainder of that matrix. And notice, you see the 1/2, the 1/4. We're doing something very important. We're using a ratio to clean up these data. Okay? We have these whole numbers, which is price, which we had done the comparison. Okay, price versus MPG, price versus comfort, price versus style. Then we say, okay, price versus price, we'll give it a 1. Because we're going to use that, and in the denominator of that ratio, we're going to put 1/2. You said, where did you get the 1/2? Well, I'm looking at MPG. Okay, I'm looking at MPG and price. Pardon me, the 1/3, excuse me. And then the 1/2 is comfort versus price, okay? And then style. The 1/2 is style. And then price. So we've used ratios to clean up the data, okay? This is not too different than what we've done. Really what we've done is we've standardized the data. We've just used ratios to do it. So that's how we get that matrix filled in. Then we sum the values in each of the columns. Then we divide each element by its column totals. And that you can look in the scoring Excel sheet, and you'll see that process. Then we're able to determine priorities on the basis of those scores. We average the elements in each of the rows. And we come up with the priorities. I want to take you back here for just a moment because I want to point out something to you. This, as we sum the values, as we work through filling out the matrix, intuitively it's quite obvious. I can see the ones in the diagonal. I can see the price versus MPG. I can see that I flipped it, used the ratio to clean that figure, that data up. Okay, and then I get the sum of those in the columns, and then I divide each element of the matrix by its column total. So now I have those ratios, all right, and using the division, I've even refined them more. And then I average the elements in the rows. So notice we've worked the columns, we've worked the rows. Okay. That's why I showed you that matrix model in those resources. In the first screencast, I said, hey, go out and take a look at this matrix to see something in nature that we can use as a tool. And as you recall, that matrix is used by folks who work with jewelry to try to determine the refraction and hence the clarity of those gems they're working with. And you can go and visit that. I have the link there for you to go take a look at so that you can see the scientific basis. Now, don't do this to make you a geek. I do this so you understand that this is a powerful tool you can use if you use it well. Now, we're going to work on through here, and we start to look about consistency issues. Okay, so we want to see how consistent is my model. And they walk us through those, the maths for each of those. And they give us another problem with selecting vehicles, and then there's the age, and then we have the criteria. And we have the AHP ranking for them. And the scoring model is over there in 14.1. And notice here, this glossary is important because we're looking at consistency and the consistency ratio, goal equations. You'll want to take a look at them now. As I mentioned to you over in Appendix 14.1, let's get over there for just a moment. And they have some really good products to work here. Problems you can work here. Now, I wanted to get you over here to the scoring model because you'll notice here's the job selection scoring model. Those criteria, remember them, the weights, the jobs, and you'll see that in the scoring, right? And they're going to walk you through that process. And what I have is I ask you to change some variables and come up with those. let's visit those for just a moment, okay? And we're gonna look at the upload the scoring. And so let's open this up here for a moment. We've looked at the AHP, okay? Pages 704 to 707 in your text, use the scoring file, okay? And so I'm gonna pop down to my desktop for here for just a minute. And I'm gonna grab those companion files from Anderson. And this is gonna be chapter 14. And here's the scoring model. And then I give you the instructions on what I want you to do. And we're gonna let it open up here for just a sec. I'm gonna move this out of the way. Here we are. And we have the ratings, the weights. And then notice we start to use the scoring criteria. We start to calculate the scores. And notice that we're taking the weight, okay, times the rating. Do the same thing for the accountant. And remember, I showed you that matrix that's based upon refraction. And you read that whole article, it's pretty fascinating to see how folks who are jewelers have a model that they use to determine how good a gem is. And then we come up with the score. And I'm going to ask you to multiply and manipulate that variable just a little bit. Now, I'll go on back here for just a minute to chapter 13. Now, back to the Anderson text. We'll look at the scoring model there. I think we looked at it very briefly, but it won't kill us to take a look at it. And here, of course, is the PDC model. We talked about that. Probabilistic outcomes. I will go back over here and I want to just back over here to the module. And I have an AHP key, and let's take a look at this for just a minute. And you're going to be using that AHP Excel file as a demo, okay? Now you want to go down into the file and you'll see. So you're probably going to ask me, where's the AHP file? Well, if you don't see this broadcast, you'll get to find it. If you see the screencast like you should, you'll say, oh, okay, it's over there in the files. And then I'll ask you to go ahead and do the work. Now, I want to show you the key. I'll go back over here for a moment. And I think I've shown you the here. Yeah, here's the XLSX. Uh, yeah, I've got it there for you to take a look at. You see, we haven't spent a lot of time doing a lot of number crunching, and we haven't done anything really terribly sophisticated. We've stuck with some pretty plain vanilla approaches here from a computational basis. But where the spice gets added there, or we go beyond plain vanilla, is the thought processes that underlie what we put in. And with multi-criteria decision making, it truly is an issue of garbage in and garbage out. That's why I think this is probably chapter 13 and 14 are probably the most important chapters, because they take us from the land of an objective function to a land of competing objective functions, some indecision about which variables I want to change, and some indecision about the constraints under which I operate, or goals. And that's what makes these the most realistic and I think important chapters in the textbook. Well, I think we've covered things today pretty well. And like I said, I'll make those keys visible for you to see and to take a look at. And I think that will pretty much do it. Now, let me just again reiterate, this week you have these pre-recorded screencasts, okay? But when you look at my schedule and when you look at the announcements here in Canvas, you're going to see that I'll be online. When I'm in Shawnee, I'll be in my office, but I'll also be online if you have a question about this course. When I'm in Oklahoma City, I'll be online during class time if you have a question about the course or a question about what we're doing in terms of this week's work or anything of that nature. So you don't have anything to cry about. Now, in addition, you can see in the schedule I sent you, I also have my virtual office hours and my physical office hours. And I can't begin to tell you, I didn't calculate it up, but you can, if you want to find me or you need to contact me, you can. And of course, there's always email. All right. So I've tried to set this up. Now you have the flex time to work on those projects. And let's go back over here to the module because I want to talk about that. Okay. Now, module 14 is these screencasts are pre-recorded for a reason. You can view them when you want to. So you don't have to spend class time viewing these. You can view them at another time, or you can view them during class time, okay? And then you can work. But you have this week to be working on these assignments. They're going to be coming due down in module 15. In fact, I gave you last week, the week before Thanksgiving, to do that. So you had flex time there. So you'll have had 2 weeks of flex time to get ready to have everything done, to do everything that's due for week 15. Now, doing that means you would have week 15 to work on stuff that's due in your final. Okay? So we're doing a little time management here. But I hope you do that. If you don't, well, I gave you the chance to do it. All right? Okay, my friends, that'll pretty much do it. And you have my schedule, so you know when I'm going to be in Shawnee, when I'll be in Oklahoma City. You'll know when I'm going to be online, when I'm going to be online and in my office in Shawnee. I don't know what else to do. So it's there for you to see. If you have questions, I want to help out. Happy to do so. Okay? I think then we'll call this a wrap and end this, and I'll stop the share. By the way, I hope you had a great Thanksgiving. I think I probably forgot to mention that. I hope you got to have a lot of good food and fellowship. And as you're on your way back home, please, 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 if you see this before you leave to come back to school, please be careful. Please. All right, I'll stop the share and then stop the recording and get this thing processed and posted.